what's up? Welcome back to another very exciting tutorial. I know what you're thinking. This guy disappeared for a whole year. 1 year, no tutorial. And you're right. But 3 things happened. Number 1. Last September here in Austria it started to rain. And I mean really rain. It poured for 6 days straight. Everything was underwater. Everything. We had what they called a once-in-a-century flood. Okay, damage fixed. Number 2. Just when I was ready to start again, I got cancer. I had surgery and yeah, there were a lot of complications, but all good now, I'm healthy again. Okay, there is a long scar on my face, but hey, who cares, right? And number 3, the good part. I suddenly had a lot of time to learn something new. I always wanted to build my own 3D models. Cars, planes, boats. Science fiction 3D models? So I spent about 3 months, 10 hours a day learning a CAD program called Plasticity. And now I can actually build some pretty good 3D models. Today we will use one of them, the Virginia class Submarine, and build a realistic underwater scene. So, without further ado, let's get started. Okay, we are in Cinema 4D and we have just imported the Virginia, the Submarine, and let's open the material editor and we see we have the base color, we have metalness, we have the roughness, we have the bump map, and with the displacement all set up in the right channel. We have add the Redshift render tag and override the geometry and set the displacement to 1 centimeter. The whole submarine is modeled in real scale. That means it's really big. Just figure out and add a person into it. And you can see with a person with 180 centimeters tall, the whole submarine looks really big. So it's modeled in real scale. It's a huge submarine. Okay, let's delete the figure and put some lights into it. I choose spotlight and we add up spotlight, change the rotation to -90 degrees. And now it's time to fire up the Redshift renderer. I have a special workspace for my YouTube channel. So I've integrated the Redshift renderer on the left side and on the right side, the perspective view. We are putting the light way up because, as I said, the ship is huge. So we are putting the light about 106 meter above the submarine and change the intensity to 10,000, a really big number, and the exposure to 16. And now you can see on the Redshift renderer that something happens. We will change the cone angle to about 73 degrees, the fall off angle about 225, and the fall off curvature about 3 to 4. And right now we can see that the submarine is enlightened via a huge spotlight more than 100 meters above. And now it's time to simulate the sky. In order to do this, I integrated a plane and put the plane also on top of the submarine, about 79 meters, and changed the width and the height of the plane itself to a very large number, so that the whole plane itself is also blocking the whole submarine again. And now we can integrate the new material. So we will add a new material, a sky material. We open up the material editor and name it sky. And in the material editor, we place the material on top of the plane. And in the material editor, we integrate a maximum noise. and the maximum noise has a very large scale. So we go into the input and the overall scale, we change it to 1800 and put the output color to the opacity channel of the material itself. And now you can see in the Redshift renderer that something is happening. Only those parts are enlightened where the light comes through the surface. And this is possible because of the material with the maximum noise shader on it. But we're missing the light rays, the God rays underwater. And this couldn't be done with an environment. And now look, it's beautiful right now. But we have to tweak the light rays a little bit because it's underwater. That means we are going into the environment and choose another tint. The color of an underwater scene, the light underwater scene is blue. So let's turn the hue and saturation to a mostly blue value. And let's crank it down, the saturation, and also a much darker blue. And then we have to play with the scattering, the viewing distance, and with the so-called anisotropy. I don't know if I have called it, if I spelled it correct. So the scattering, we are changing it to a value of about 1.6. We are much blown out. That doesn't matter because we will change it later with another setting. The viewing distance, we are setting it to 0. And the anisotropy, it's the value where you can change the light rays about their distance. So I'm setting it to a value of about 0.2 or 0.3. So let's try 0.224. It's okay. And then we are changing the ray contribution scale. That means how much rays are the camera are seeing. And now we are cranking it all the way down to 0.006 is a very small number. Crank up the reflection to 1, the global illumination also to 1, and the environment fog also to 1. And now we have a very good setup for the next step. And I think we are seeing the light rays coming under the surface. And yeah, it looks beautiful. The next step we are changing is the camera setting, the right camera setting, and almost what is very important for underwater is the right setting of the chromatic aberration. But this will be done in the camera settings afterwards. Right now we see that when we change the position of the submarine itself, the position of the sun isn't changing, of the light isn't changing. Therefore, we have to integrate a null object, place it underneath the submarine, and within the null object, we are placing it the Redshift spotlight. This means that the spotlight itself is moving within the submarine, and we will see that the light rays are changing their position, are changing the right angle within the surface above. And this is a very important step when we simulate an underwater scene, that the spotlight itself is constantly moving with the right position of the submarine itself. So the next step is to integrate the camera. I usually tend to film with an 50 millimeter length. 50 millimeter length is more or less the same eye perspective, the human eye perspective. Then I change the depth of field to have the right depth of field, and I usually tend to simulate the depth of field with a null object. So I include a null object in the scene, change the position in front of the submarine, and I place the null object into the object of the depth of fields of the camera. This means when we simulate the aperture of, let's say, the aperture of 0.01, so the minimal length we can see in the Redshift renderer of the left side, that we can now simulate with a null object the right position of the camera depth of field. And this has a lot of advantages. Let's increase the aperture of 0.1. And there is a bonus tip. You can also right click on the Redshift camera. And in the display setting, you can change the display to the focal plane. And right now, when you simulate the focus point, the null object, you see exactly where you have your focus distance and which parts of the submarine is in focus and out of focus. You can also display other informations like the grid or the triangles or the crosshairs. So this is very interesting and sometimes very important to have such information of the camera itself for the compositing stuff. Right now we are turning it off, and we are changing the next step of our camera settings. Right now the light rays underwater are looking fantastic, but we miss some chromatic aberration where the light rays are hitting the submarine itself. So it turned out that I have to read the documentation and there I found a very good information about chromatic aberration. When you integrate this picture of the documentation in the image slot, then you have a perfect rendered chromatic aberration. I'm using a Windows PC and I clicked Shift Start S and captured a screenshot, and within the screenshot I cut it out and saved it as a JPEG file on my hard drive, and then I can use it within the camera settings. So I clicked the image and then I choose the JPEG. I just made a screenshot of it, and right now we have the right chromatic aberration, which looks absolutely stunning. You can see it right now on top of the submarine. It looks fantastic. So the light rays are coming down to the submarine and the chromatic aberration is calculated from the Redshift renderer itself via the image we have just imported. Yeah, it doesn't matter what angle, it looks absolutely perfect. So we have the right light rays, we have the simulation about the underwater, and we have the right chromatic aberration. And when the submarine itself is moving, we have some keyframes, start and the end. So it's moving, and you see it looks absolutely perfect. We have the right depth of field. So yeah, since we will be using quite a few modifiers, null objects and camera tweaks to build the underwater scene, it's not something you can easily recreate from scratch. So you can download the entire project file, including the detailed submarine 3D model for your own projects, the Substance Painter file and all camera settings and simulations, just for $30. You will find the link in the description below. If you like this tutorial, please give me a thumbs up, leave a comment and subscribe to my channel. I would be very happy to stay in touch with you. I'm really happy with the scene. I'm really happy with the results, but we are missing something. I miss those tiny plankton particles drifting around our camera. From my point of view, it's a little bit too clean, the ocean. So let's build them now, and we can do this with the built-in particle system within Cinema 4D. Right now we are going into a new scene, and let's build them up. We need a volume emitter and a volume collider, and the particles are floating around these two objects. The emitter and the collider itself are just some simple boxes, and the collider has a little bit more scale of the emitter. So they are really huge because we need really some depth of it, and we are cloning the emitter to rename it as the boundary, as the collider itself, and the size of the boundary is a little bit bigger than the emitter itself. We are adapting the size on every axis, on the X, Y, and Z. And then we are making the emitter and the boundary itself invisible for the renderer itself and in our camera position. We integrate a mesh emitter and integrate the emitter in the geometry. We are changing the source to volume and leave anything on default except the emission mode. We are changing it to a shot and give it a count of 5,000 particles. And then we are changing the property and the speed from 100 centimeters to 200 centimeters. Then we are changing the frame count from 90 to 300 and give it a try. Let's run the simulation. And we see our particles are moving with the speed of 200 centimeters. But we now need the boundary because the particles are flowing away. So we need a collide object, a collider, and tell the system that our boundary is our collider object. This will be done with the simulation tag. And in the simulation tag, we are changing the collider side from front or back to both sides. And then we are integrating turbulence effect. Here is the turbulence, and change the strength to about 50 centimeters. Let's give it a try. And right now we are seeing that the particles are colliding with the boundary, and it looks absolutely fantastic. So also the speed, we can change the speed. We can also change the scale of the turbulence itself. Let's give it a try to change the strength from 50 to 100 centimeters. And right now you can see the particles are moving much faster because we changed up the strength. From my point of view, it's a little bit too fast. We are going back with the strength to 50 centimeters. Let's play with the scale from 0 to 10%. But from my point of view, I like let's move it down to 4% or 3%. No, I will go with 0 scale. And from my point of view, it looks absolute fantastic. We are now adding a null object and include everything from this particle system into the null object. And then we have a particle rig system. We call it particle rig and give all the emitter, the turbulence, the collide, the mesh emitter, and the particle group itself into the null. We are copying it and paste it to our scene. And right now we are changing the position of the rig system itself so that the camera itself is integrated within our complete particle system. That means that the plankton particle itself are floating around our camera system. Let's give it a try, and I have some problems with my Redshift. Oh, I see. It's always the same because I changed with my scroll wheel of my mouse. I changed the size from 100 to 0, change it back, and now let's play it. And Let's see what we get. Our particles are emitting and our camera is in front of the mesh emitter, but we see nothing, and that's because we need a render tag on the particle group itself, a Redshift render tag, and tell Redshift that the Redshift has to render optimized spheres with a scale multiplier of 3, and then we see the particles flowing around our camera. Let's crank the scale multiplier to 4. Let's give it a try. But before we are playing with our particle system in our scene with the submarine, we will cache the whole particle system because it's much easier and much quicker to go with a cached particle system. Therefore, we are going into the rig system, into the particle group, and cache the whole simulation. Cache the object and give it a name. Let's find a new folder. Let's call it test cache, and within the test cache we are changing the file name to test cache and cache the whole simulation. Okay, we are right in business, and now we can scroll through the whole particle system with our mouse much easier and much quicker, and we can adapt the simulation itself and move the simulation to the right camera angle as we would like. Because we have a cached simulation, we also have the possibility to turn on the motion blur, and let's see what we get when we turn on the Redshift renderer, make it much bigger, and we see we have green particles, we have a green plankton. That's not what we want. Let's change it to a particle which has a plankton of a white and a transmission of about 0.2, and give the particle group that information, and give it another try. And right now we see much more the plankton itself, but it's way too big. So we go into the Redshift render tag and move the multiplier down to 2.5. Let's give it a try. Yes, much better. And maybe a little bit too big. Let's try it 2, and with motion blur we are getting there where we want. It looks from my point of view it looks good. Maybe a little bit too big. Let's play with the animation itself, and we see that the plankton is moving. We see the camera animation, we see the chromatic aberration, and it looks a little bit too big, so we will move down the scale multiplier to 1.5. Yeah, right now we are in business. That looks perfect. Look, the chromatic aberration on the back side of the submarine and on top where the light rays are coming through the surface. Wow, from my point of view, it looks perfect. It looks absolute gorgeous. So we have a plankton rig with particles. We have the camera system. We have the submarine and the surface, the light rays coming through the surface. What we now need is that the plankton itself is moving, the whole rig, particle rig, is moving within the camera itself. So when we change the position, when we change the rotation, the whole particle rig should be changed as well. So we need the same trick as we have done with the surface. We are integrating the whole particle rig into the camera itself. So we integrate either a null system or we integrate the whole particle rig itself into the Redshift camera. And when we do this, we see that when we are changing our camera, the whole particle are also changing their position. Not only the position, also the rotation. When we rotate the camera, the particles are also rotating with the camera angle. So this means that it doesn't matter where our camera system is, we have always the same particle rig, always the same planktons are moving within our camera and around our camera. So let's give it a try how this is rendered. And the animation. The depth of field from my point of view is also very, very stunning. It looks absolutely perfect. And with the right motion blur, you see a very gorgeous underwater submarine scene. I love it. I love it really. Okay. Let's play around with the position. And you can see the chromatic aberration on top of the submarine, of the side of the submarine, and in the back. Wow. Yeah, from my point of view, it looks perfect. Thank you for watching. Again, if you like this tutorial, please give me a thumbs up, leave a comment and subscribe to my channel. I will be really happy to stay in touch with you. And we will see you next time. Bye.